So welcome to Math 2526. So today's topic is sampling distribution. Okay. So last class we discussed the central limit theorem. So central limit theorem is thus, like if we do something many times, then the total result will follow normal distribution. So total result will follow this normal distribution. So mean is n mu and variance is n sigma square. But the standard deviation is take square root. So for normal distribution, we prefer standard deviation instead of variance, right? So now let's consider this problem. I suppose for a game, for a simple game, we find mu is negative 0.1 and sigma square equal 1. So mu is negative. So this means this game is not in favor of you. So if you play this game many times, play 100 times, then we want to find what's the probability that you can win some money. So we want to find this probability. Totally, so this is positive you can win some money. Okay, so here t is, we can regard t equal the outcome from first game, say, plus outcome from second game, right? And from 100 game. So we win some money or lose some money, we're talking about the total result. We don't care what is the value for x1 or x2, right? We just check the total result, t larger than 0. So what is such probability? So for this problem, at first we need to know what is distribution for this t. So we know this t follow a normal distribution. So n mu n sigma square, take square root, right? So this t follows such normal. So we plug in here mu equal negative 0.1, n equal 100. So we know this normal distribution is this normal. So here negative 10, right? And n sigma square is 100. So 100 take square root is 10. So we know total result will follow such normal distribution. So for such a normal distribution, we want to find the probability. So we say first step is just changing this to z, right? Changing this to standard normal. So larger than, so this number minus mu, mu is negative 10, minus mu divided by sigma. So this number, just a little bit calculation, we find this equal 1, right? So we just change 1 as 1.00. So to find this probability, we need to check standard norm, check z table. So where is z table? So we check z table, check 1.00. Check 1.00, 1.00, this number, 8413. But this 8413 is less than, right? Left side. So larger than should be 1 minus 8413. So we get this answer is, let's say 7, 8, 5, 1. Oh yeah. Okay, so we can say almost we have a 16% chance to win money. So this also implies we have a 84% chance to lose money, right? So here win some money, here lose some money. So we can say that the chance for lose money is much higher than the chance for win some money. So for such game, we should not play many times, because this game is not in favor of you. Mu is negative, right? Okay, so this is a typical application for centrally limit Thalian. So like if we play game many times, the total result will follow normal. So we can find the probability about the total result. The total result will you can win, or you can win certain number of money, or you can lose some money, right? Okay. So so this is centrally limit Thalian. We have another version. So here let's say we have like a positive summation for total result, x1 summation for x1 and x2 and xn. Then this t total result will follow this normal. Okay. But now let's consider the average. So t divided by n, or thus x1 plus x2 plus xn divided by n. So this is the average. So we denote this as x bar. So the x bar, the t follow normal, then divided by n is also normal. So we have this like divided by n, so n mu. So we just divide by n. We just each one we just divide by n. So n mu and this radical n sigma square. So this divided by n mu, right? Become mu, and this divided by n. So this divided by n. So n equal radical n sigma square, take a square root, then n radical n sigma over n. This equal so sigma over radical n. So we get this. We say the x bar follows this normal. So such a result, we refer this as a sampling distribution. So we say this result, x bar follows this normal and t follows this normal. These two things actually the same, but we will use different name for them. So we call this t or centrally limit Thalian. This x bar, we call this as sampling distribution. So why we call this as sampling distribution? Not that we just say why we need to use a different name for the same thing. So we can say because like in statistics, a really common story is, okay, so here we have a population. We have we have many people. So for them we have the average mu and their difference, average difference of standard deviation sigma. But these two things we don't know because the population too huge. Right? So usually we will check take a sample, we check a small part of a population, check a few people, so we say we take a sample. So from the sample, we can find their average, right? Samples average x bar. So we need a samples average, samples information to check a population's information. Go back, right? So I go from sample, go to population. So this is the typical issue in statistics. So we say for this thing, so we say like this x bar follow this normal such result in statistics. We call this a sampling distribution. So we can say this in stats, we call this as a sampling distribution, and in gambling, we will call this as essentially limit salient. So both of them essentially the same thing, but in different discipline, right? In probability, we call essentially limit salient. In stats, we call this sampling distribution. Okay. So this essentially limit salient or sampling distribution just conform a common sense. So we have such a common sense. Like we say, blame one people, few people is okay. Like blame many people, not so okay. Or like if we pick, let's say, like if we pick one bad guy, such probability, such a chance is high, maybe, right? But if we pick a bad group, such a probability should be small. So let's confirm those things. So let's check this example. So now suppose like we let X be the exam score for Math 2526 in this school. So we assume like we have many Math 2526 students. So we have this information. We know mu is 82. So here the average for all people is 82 and sigma is 5. So this is population information. So we know this. And we also can assume this X follow normal distribution, right? X follow normal distribution. So mean 82 and standard deviation 5. Okay. So those are information for all students. Okay, average is here 82. So now let's check this. If we pick one student randomly, so this student score can be here or here or here or here, right? So we want to find what is the probability that this student's score is less than 78. So here 78. So we want to find this probability. This probability is just a percentage for people that score less than 78, right? So we know such a problem is easy. We just need to find this probability, right? Okay, so those problems, so by now we are quite familiar with. So first step, changing general normal to standard normal. So minus mu divided by sigma. So this equal, I think the last thing, so a little bit calculation for this is negative 0.8 is 0, right? Okay, so then check the table. We just check a positive a 0, but this we should use one minus, right? Yeah, check a positive A0. A0 is 7882. 7881. 7881. So 7881. But here's a negative, so we should use 1 minus. Yeah, don't forget it's 1 minus. So we find this equal, let's see, 9112, right? So we say such a chance is about 21%. So 21% people, 21% chance that the students score is below 78. So we also, if we really got a 78 is a cutoff point for better score or good score. So we say 21% chance for better score. Okay, so now let's check there's a problem. If we pick 9 students, so we want to find that their average score is less than 78. So there's a time we talking about the average for those 9 students. Their average will less than 78. So there's a probability we can understand. We pick a better group. All those 8 on the average, there's the 9 students not so good. So what is such a probability? So at the first we need to find the distribution for x bar, right? So we know x bar. So by sampling distribution, x bar is follow this normal. So we plug in here mu is 82, right? And sigma is 5. And n equals 9. So take a square root of 9 is 3, right? Or we put it here as a formula 9. So this equal mean is 82, and this is 5 over 3. So let's check this number. 5 over 3 equal 1.67. 1.67. Okay, so now the problem becomes like this. We know x bar follow this normal. Mean is 82, standard deviation 1.67. So what is this probability? So such a probability, first step changing this to z, right? So less than this minus mu, mu is 82, minus mu divided by sigma. Okay. So after a little bit of calculation, so what is this number? This number, so use a calculator or whatever we can use. This equal this -4 divided by 1.67. This equal negative 2.40. Okay, so now we just check the table, find there is a probability. So we just check 2.40. So again, here's a negative, less than negative. So this we should use this 1 minus, right? 1 minus, so 2.40. 2.40. 2.40 0, 2.40, thus 9918. So 9918. 9918. So this is 9918. Okay, so this probability is very, very small. 0, 0, like 8, 2. So this probability is very small, less than 1%, right? So we can say if we pick 9 people, 9 students, their average less than 78. Such a chance very, very small. So we use probabilities to compare, to check like what is the chance this thing happen, what is the chance that thing happen. So let's consider there's a problem. Whom to blame? Like suppose we know for all people, for students, their GPA average GPA follow this normal distribution. So mean is average GPA 3.1 and standard deviation 0.3. So in our class, we have 25 students. So in some exam, our class did very bad. So in this case, whom should be blamed? The teacher or the students? So students will complain this is because our professor is not so good, our teacher is not so good, right? His teaching is so bad. But for teacher or the professors, they also wanted to defend themselves. They wanted to say, this is because of this class, the student in this class is quite poor. So we need to judge whose claim is more likely to be true. Or we need to check the probability. So let's check the probabilities that the professor's claim is true. So we have two cases: either professor's claim is true or student's claim is true, right? So how can we make a judgment? So we just check the probability. So the professor's claim is students are quite poor, weak. Students are weak. So how can we judge weak? How can we say weak or not weak? So here we just assume if weak means class average GPA is less than 3.1. So we just need to find this probability. What is the chance that class average is less than 3.0? Like suppose like our in class average GPA we find only 3.0, but for all other students average is 3.1, right? So we can regard average GPA 3.0 is weak because of below the average for all other students. Okay, so here we say from our class we can find this equal 3.0, but the probability for bad means like so we cannot find this probability. Let's say I'll put it here. We cannot say what is this probability. So this because here x bar follow x bar is we're talking about a continuous distribution. So x bar equals this number. So okay, 3.1 here. Exactly equal this point, such probability is 0. So bad means like less than this part, right? Less than 3.1 or 3.0. Okay, so we should not check this probability. We just check this less than or equal. But again, for continuous distribution, equal not equal, include this point or do not include this point, doesn't matter. So we just check this probability. Okay, X bar. So to find this probability, in order to find this probability, we need to know the distribution for this X bar. Right? We need to know the distribution for X bar. So here X bar follow this normal. Mean is say mean 3.1. Then sigma over radical n, sigma is 0.3. Sigma over radical n. So here n, I remember n is 25, right? In our class, we have 25 students. So radical n is 5. Okay, so this 0.3 over 5 is 0.06. So we know the class average should follow this normal. Mean is 3.1 and standard deviation is 0.06. So then what is such a probability? What is this probability? So we say there's changing this to z or less than, so 3.0 minus mu 3.1 divided by sigma 0.06. Right? Okay. So then here a little bit of calculation. So that's equal, let's say 3.0 minus 3.1 divided by 0.06 equal negative 1.67, right? Okay. So there's a probability. So we check positive, check 1.67, positive 1.67 from the table. So let's go to the table. 1.67. So 1.67 here, right? 7, yeah, 1.6789, so 7. So this is 9525. So this is 9525. Okay, so we can say this probability is almost 5% of 0.05. So we can regard this is the probability that the professor's claim is true. This is 5%. 5% chance that the professor's claim is true. So this also implies 95% chance that students' claim is true, right? Yeah. So we should believe students' claim. We should believe the student claim is true, or the professor's teaching is bad. So whom should be blamed? We should blame the teacher. If such a thing happens, we usually will blame the teacher, right? Okay. So we say that this is some example for sampling distribution. So sampling distribution, we say this is important, and we can say this is a bridge connecting the probability and statistics. This is also with the foundation for statistics. Okay, so we say those problem. So far, the problem about the probability problem. But let's check this problem. So this looks like a statistical problem. Let's say, like we just use say, let's say, like some people just claim this, claim there are no information for all people, all students, right? So here, GPA for all students in this university follow this normal distribution. Mean is 3.1 and the standard deviation 0.3. So, but so there are the other people's claim. But I find, or a professor find, in our class, in this class with 25 students, we find this average only 2.9. So this 2.9 is less than 3.1, right? You say average 3.1, but I find in our class, I found average is only 2.9. So can we believe their claim, or can we reject the claim? So such a problem is just like that's a problem. We have the information from the sample. So from the sample, we want to make a judgment. We will check their whether their claim is true or not true, or can we believe them, or we should not believe them. Okay. So can we reject the claim, or can we can or we should reject them, or we should believe them or reject them? Depends on probability, right? So we want to find, like here, let's say, there's say average is thus, but we find in our class 2.9. So we can say like the 2.9 is less than this, or we just find this probability. So bad. So cannot be exactly equal, right? So we just check this probability. What is this thing happen? If that claim is true, but this thing happen by chance. So we want to find this probability. So if this probability very, very small, then we will say such a thing should not happen, right? Probably very, very small, we say those things should not happen. So then we will reject the claim. Okay, so find this probability. So by now we know how to do this. In order to find this probability, we need to know this distribution for x bar. So we just find this x bar is means 3.1, standard deviation 0.006, right? Yeah, we just did this before there. So sigma is 0.3. Let's review this. Sigma over radical n, which is just 0.006. Okay, so x bar follow this normal. So then find this probability. So change this to z less than 2.9 minus mu divided by sigma. Okay, so what is this now? So let's check a little bit, or calculate this. Calculate a little bit. This is, let's say, like let's see, no, let's say like a no. this divide by 3 point or negative 3.33. So negative 3.33. So we just check the table 3.33. So again, so this equal. So we should use this equal 1 minus this number, right? We put it here. Okay, 1 minus. So we check 3.33. 3.33. So 3.33 is 9996. Okay. So this is 1 minus 9996. So this probability is very, very small. So because this probability is very, very small, so we can say we should reject the claim. The average GPA for all students cannot be so high, cannot be 7.1, because in our class average only 2.9, right? So this problem looks like a statistical problem. So we can say like sampling distribution is just the connection between probability and stats. Okay. So from today's class, from later on, we will move to statistics. Before we can regard those are all probability problems. So connect them is centrally limit or sampling distribution. Okay, so we can stop this class. So see you next class.